Okay, today your assignment, part of it is going to be graphing equations in slope-intercept form. We have already gone over some of this in class, but I just want to do a little refresher before you guys start. So, first, what is slope-intercept form? Slope-intercept form is a way of writing a linear equation. And the format for that is y equals mx plus b, where m is the slope, remember that's rise over run, change in y over change in x, and b is the y-intercept. A y-intercept is where the graph crosses the y-axis. So in your packet, number 1 looks like this, and we are going to do this one together. So whenever you are graphing an equation, first you want to look and say, okay, is this in slope-intercept form? And the answer is yes. It's in that y equals mx plus b format. When you go to graph, you always want to look at the number that is added or subtracted to the end of the equation, or sometimes it's at the beginning, but it's the number that does not have a variable next to it. In this equation, we want to look at the -1, which I have highlighted in yellow. That is our b value. Our b value, that's the y-intercept. That's like our starting point. So on the y-axis, you want to go to -1. I'm going to get the creative pen out here so we can see it a little bit better. You want to go to -1, I'll use a smiley face, and put a point there. That is our starting point. So the first step when you're doing this is to plot the y-intercept. Put a point on the y-intercept. Next, we're going to have to look at the slope. We need to figure out how many do we go up or down, how many do we go left or right until we put our next point. So here, the slope is 1/4. 1/4. 1/4. So we're going to go back to our smiley face here, to this y-intercept that we plotted. The slope of 1/4, remember, it's rise over run. So it's telling us we're going to go up, let me get back on the smiley face, 1 unit, and over 1, 2, 3, 4 units, and put our next point. Now, we can't go up 1/4 again, we'll go off the graph, but there is room for us to put some down here, put some more points on the graph. So now back to our y-intercept, we're going to go down 1, 1, 2, 3, 4, to the left. And then we're going to connect those points using a line. Now you do have a ruler. The sub should have passed them out. And if you don't, I want you to stop this video right now and go get one, because I want to see straight lines with arrows on the end of them. So here, what do I need to do? I need to go back and add some arrows, because that means that line, that the arrows, oh no, technical difficulties. The arrows mean that this line is going to continue extending forever in both directions. If you notice here, our slope was positive, a positive 1/4, and our line is going uphill from left to right. So that's how we know we have a positive slope there. So the whole first page of the packet, front and back of the first page, is graphing lines in slope-intercept form. The second page of the packet gets a little complicated. It looks a little different than we've ever seen before. But we're just going to use everything that we know about graphing equations in slope-intercept form to put 2 equations on one coordinate plane. So if you look here, we have 2 equations. We have y equals 4x plus 3 and y equals -x minus 2. This is called a system of equations. A system of linear equations, if we want to be more exact, because these are both linear. How do we know they're both linear? They're both in y equals mx plus b form. So let's graph them. The first one I'm going to graph using, not that. we'll use stars. So y equals 4x plus 3. Again, we first want to look for the y-intercept. Where does this graph cross the y-axis? What is our starting point? It's 3. So we're going to go to the y-axis and put a point at 3, like this. Now, it's a little tricky when we go to look at the slope because we think the slope is 4. Typically, we see the slope as a fraction, rise over run. But we just have to think, how can we write 4 as a fraction? So the slope is 4, but if we want to write that as a fraction, it's like 4 over 1. Whenever there is no denominator, the denominator is 1. Now it looks a lot more like we're used to seeing. We have the change in y over the change in x, or the rise over the run. Now we can use that to put some more points on our graph. You'll notice that if you try to go up 4, you can't. You're off the grid. That's okay. We can't go up 4, but can we go down 4? Yes. And then we go over 1. Then from that point, let's see, can we fit another one? Down 4, over 1. Those are all of the points we can fit. So now we need to connect those points with a line. And remember, we want arrows on both ends of the line. I'm going to make this line blue. All right, so we've graphed one of the equations in our system of equations. We've graphed the top one with the stars. Now we need to graph the second one. So for this one, we will use this little tie-dye circle. So again, the first step is figuring out what is my y-intercept. Where do I start? I'm going to highlight it in blue. The y-intercept here is -2. So we're going to go to -2 on the y-axis because it is a y-intercept, and we're going to put a point. From here, we need to find our slope. So it says y equals -x. So m equals -1. When there's no number in front of the x there, it's like a 1. So we know that the slope is -1, but again, we're used to seeing slope as a fraction. So how can we write that -1 as a fraction? We could say m equals -1 over 1. Whenever you do not have a denominator, remember that the denominator is 1. And now we can use that slope to graph our equation. So from the y-intercept, we're going to go down 1, over 1 to the left this time. Down 1, over 1 to the left. Down 1, over 1 to the left. Now we're going to go back to that y-intercept. We can still put some more points going this way. So we're going to go up 1, over 1. Oh, look. We put a colorful dot right on top of a star. Start thinking about what that means. Up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And now we're going to connect these with a line that has arrows on the ends because it's going to go infinitely in either direction. And again, you can see the red line, we had a negative slope, so it is going downhill from left to right. When we were plotting that, we noticed that in a certain spot, we had a star and a tie-dye dot on the same ordered pair. That ordered pair right here that I'm going to highlight in yellow, but it's going to turn blue. Okay. I'm going to undo that because I really want it to be yellow. Okay. This ordered pair that I'm highlighting here, where we have the star and the dot overlap, that is the solution to a system of equations. So the solution to a system of equations, is the ordered pair. Remember, ordered pair is a coordinate, x, y, where the lines intersect or cross. Intersect is just a more formal word for cross. So what we're trying to figure out is, to solve a system of equations, we need to know, where do the two lines meet? Where do they intersect? Where do they cross? What is that ordered pair? Sometimes they won't intersect. And we will get to that more when we get deeper into systems of equations. But this is just a brief introduction using what we know about graphing lines to find the system to find the solution to a system of linear equations graphically. So to find the answer, we need to take these coordinates that are highlighted in yellow, and we need to write it as an ordered pair. I'm going to do it in purple. So if you look, to do this, we go over 1 to the left, so the x value is -1. And then we go down 1, so the y value is -1. -1, -1, this is the solution to the problem. It is the ordered pair where those two lines intersect, where they meet, where they cross. So for the second page of the packet, it is all systems of linear equations. So you're going to graph both equations on the same grid and find the point where they intersect. Two lines always intersect at a point if they intersect. And then you want to write that ordered pair either on the grid or next to it. That is your assignment for today, to finish the packet. And if you do not finish it, it is homework. So assignment, complete the packet that was handed to you. What you don't finish is homework. Email me if you have any questions. And I will see you all tomorrow.